let's try this one. It says predict the molecular geometries in H3BO3. So the first thing we have to do is who's the central atom. So go to my periodic table. H is never in the middle. So is it B or O? B is less electronegative, so it's going to be the B. So B is going to go here, and then I put my O's around. So then I have to decide, well, where do the H's go? Do the H's go on the B or the O? So we should remember that B is one of those exceptions, and that he is happy with only 6. He doesn't want 8. So if he's happy with less than the 8, he's not going to want to have all 6, all 3 hydrogens and all 3 oxygens on him. So that means that those hydrogens have to go on the oxygens. All right, now I'm going to add it up. Hydrogen has 1 valence, boron has 3, oxygen has 6. So hydrogen, I've got 3 of them, each with 1. Boron, I've got 1 of them with 3. And oxygen, there's 3 of them with 6. That gives me 24 valence electrons. I make single bonds, 1, 2, 3, 4, 5, 6 single bonds, so that's 12 electrons, because there's 2 electrons in every single bond. Now I make the outside guys happy. Hydrogen wants 2, he has to, he's good. So all the hydrogens are good. Oxygen wants 8, he has 1, 2, 3, 4, so he wants 4 more. And all the oxygens are the same, so I give all of them 4 electrons. So that's 4, 8, and 12. So that is 12 electrons, which I had, so we're good. Then I go to the central atom. Boron has 6, and he wants 6, so he's good. And since he wants even less, I don't worry about expanding or anything because he's one of the exceptions with happy with less. So this is my Lewis picture. So now I want to talk about the geometry. So if I want to talk about the geometry, I need to talk about it for the B and for the O, because the B is in the center, but then the O is also in a center position. As long as it's not at the end, if it's between 2 things, then you need to talk about its geometry. So let's talk about the boron. How many electron groups? 1, 2, 3. So 3 electron groups, and they're all 3 bonds. So this is a 3, 3, 0, which is our trigonal planar. Okay. Then we look at the oxygen. 1, 2, 3, 4. So 4 electron groups, 2 bonds, 2 lone pairs. This is really common for oxygen. You'll see it a lot. So this is a 4, 2, 2, which is that bend. So then you would just write the geometries for each one, and that's it. So you write what it is for the boron, for the oxygen, and that's it. If I ask you for the bond angles, then you give me the bond angles. This is exactly 120. This is less than 109.5. Okay? So now we're going to switch gears and we're going to talk about a new concept in the next lecture, and that new concept is called polarity.